Hello and welcome to this lesson on solving polynomial equations in factored form. So this is the first time we're going to talk about factoring a little bit. That is what we're going to focus on the rest of this unit. So we did a little bit of adding and subtracting in one lesson. We did multiplying over the course of 2 lessons. Now we're going to do factoring for the next about 5 lessons, because factoring is like one of the main things that you do with polynomials. You factor them, you combine them together, you solve equations, and the solving equations is kind of what we're focusing on in this lesson. How do I solve polynomial equations? Okay, so before we get to that, if you could please pause the video and see if you could find the mistake in this problem below. There's one thing that stuck out as a sore thumb to me when I first looked at this was there's no way that this final answer is right, because this 3 times this 3 should give us a -9 somewhere. So if we multiplied 7x times 7x is 49x squared. That looked okay. And it looked like this might be one of those sum and difference patterns where the middle term cancels. So that would give us -21x positive 21x, but again, 3 times -3 should be a -9. So when these middle terms cancel out, this dude right here is the problem. He should be a -9, not a +6. All right, 2 vocabulary. One is a root. This root comes into play when we're going to talk about functions a little bit, which we will. We'll do a little bit of function notation, but a root is a value for which a given function equals 0. So, here, a little weird other notation. F of x equals 3x plus 5, whatever. If I'm looking for the root of this function, all I'm going to do is I'm going to say, okay, this piece here, this actually, for us, acts kind of like our y variable, okay? So I'm going to say, okay, well, I'm going to set it equal to 0. This, if I would solve this equation, would find the root of the function, okay? This is weird. We haven't really seen this. We're not going to see a whole lot of it. But this zero product property, we're going to see a lot of, because we're going to do this in almost every single problem. So here's how the zero product property works. Think about it this way. If 2 things are being multiplied together and the product is 0, the answer is 0, then one or both things must be equal to 0, right? Like, if something times 5 is 0, well, that something has to be 0. There's no other way around it. Or another example, if 3gh equals 0, well, you know the 3 is not 0, so either h is, or g is 0, h is 0, or both, ooh, typo, that's a t, or both g and h equals 0. Okay, so that's what the zero product property tells us, is that if you have 2 things that are multiplied together and they equal 0, one or either of them are 0. Now, how does that work in a problem like this? Well, it actually works out fairly easily. Again, if this piece here times by this piece here equals 0, then what we can do is say, okay, fine, well, if x minus 5 equals 0, or x plus 3 equals 0, look what we have. We've now broken down this polynomial, or it's still a polynomial, but we've broken down this problem into 2 smaller, simpler equations that we can solve. Add 5 on both sides, and x equals 5. Minus 3 on both sides, and x equals -3. These are the 2 values that make this true. If I would plug in a +5 for x in both of these, here, 5 minus 5 is 0. 0 times by, I don't care what this is, it'd be 8, but 0 times by 8 is 0. So 5 is a value that makes this whole side equal 0. Just like -3. Because -3 plus 3 is 0. If this whole piece is 0, 0 times by -8 is still 0. That's the zero product property. If you have your problem set equal to 0, you can break it down into either the first piece is 0 or the second piece is 0. And by the way, this works if you have 3 pieces. If there's 3 binomials multiplied together, 3 terms being multiplied together, one of them has to be 0. So you can set each of them equal to 0 and see where that gets you. And then you solve. Now, pretty soon, I'm going to start skipping some of this work because, well, you should be able to solve an equation relatively quickly in your head, and it's just less work for me to have to write out. You don't have to listen to me and watch me solve equations. But I will for the first few problems. And those are our answers. If we plug those values in, just like I showed you previously, that would make this side equal 0. This one would make this equal 0. -5 plus 5 is 0. If I plug -3 in for both, it would make this one equal 0. 2 times -3 would be -6. -6 plus 6 would equal 0. And so the whole thing would equal 0. So that's our zero product property. I would like you to try 2. So go ahead and pause the video, do these 2 right now. When you're ready to continue, hit play, and we'll go through them together. All right. So we say, okay, either m plus 3 equals 0 or m plus 1 equals 0. You solve those equations taking only one step. You minus 3 on both sides. M equals -3. You minus 1 on both sides. M equals -1. And you're done. That was a very simple, quick problem. Letter D. Well, m plus 1/2 equals 0, or 2m minus 1 equals 0. I'm going to skip a little bit of work here. This makes m equals -1/2, because I would have subtracted 1/2 on both sides. Over here, I would add 1 to both sides, divide by 2 on both sides, and those are my solutions. I got a positive 1/2 and a negative 1/2. Now, this is a kind of big change of pace in the middle of the lesson. We're going to come back to what we were doing with the zero product property in a second, but we're going to start talking about factoring a little bit. This is the very first time that you'll be factoring polynomials. So what we're looking for here is we want to factor out the greatest common factor. So looking at these, we're going to try to pull out, like reverse multiply is really what we're doing. Reverse multiplying whatever we can. So do you see anything that these two terms share in common? I start by looking at the numbers. Yeah, I can pull out a 3. Imagine I did that. I would have a 4x plus a y squared. This is what I'm talking about with this reverse multiplying, because I could re-multiply this back out if I would distribute this, and I would get back to the original problem. That's factoring. I've just factored a 3 out of this. It's almost like dividing, but I'm not using divide. What can I divide both of these things by? Common multiple is 3, or common factor is 3. Now, we'd also like to be able to do this for our x's and our y's. But this guy has one x, and he doesn't. So they don't share an x. I can't pull out an x. This one only has y's, and he doesn't. So they don't have any y's in common. I can't pull out a y, so this problem is actually done. That 3 was the only common factor. And by the way, this 3 right now, would be the greatest common factor of that binomial. So if the problem said find the greatest common factor in this problem, it's 3. It's the biggest amount of stuff I could pull out of the problem. Letter B. First thing that popped in my head when I saw this is the 3 and the 15 have a 3 in common. I can pull a 3 out of both of them. Then I'm going through each variable one at a time. G's. Do both of them have G's they can give up? No. The second term does not have any G's. Okay. H's. Do they both have H's they can give up? Yes. How many H's? What is the maximum number of H's both terms can give up? The answer here is only 1. My first term here only has 1 H to give up, so I can't take 3. He doesn't have 3 to give. He has 1 he can give, and so he'll give 1 too. Now, what would this look like after the factoring? Well, think about it. We divided, factored a 3 out of this, so that would become a 5. We did not touch the G's, but we did factor out this H. Now, if you look at it, if I would re-multiply this back out, if I would take this 3h times by that 5g squared, we should get this first term back out. 3 times 5 is 15. G squared times h is g squared h. So that's good. Our second term, I divided by 3. I factored a 3 out. So that first 3 is gone, and 1 of his h's are gone. And you know you did this right. If you would multiply this back together, you would get back to the original problem. And I think we do here. 3h times by h squared would be 3h cubed. This first piece, the 3h, is our greatest common factor. Two for me, 2 for you. Go ahead and pause the video and see how far you can get. See how many common factors you can pull out. Find the greatest common factor. So in letter C. So I see we can pull out a 3. But you know what I would do? I would pull out a -3. Because I see both terms here are negative. The 12 is negative, the 3 is negative. So why not pull out a -3? I see both terms can give up 1m. I can see both terms can give up 1k. And that's it. That's their greatest common factor. Now, what's left behind after I factor this stuff out? Well, inside of the first term, we would have a 4, because -3 times 4 is -12. I don't need an m here because he's sitting outside. I don't need a k because he's sitting outside. I do need a z. So these two multiplied together would give us our first piece, our first term. Second one. Well, I don't need the -3 inside because he's on the outside. I don't need this m. I don't need one of the k's, but I still need this other one. And we'd actually need a plus in here because the negative is sitting outside. If I would multiply out this -3mk with k right now, it would give us this exact back. But if I left this as a minus sign, like this, then -3mk times -k would give us a positive 3mk squared, and we don't want that. We want it to be a negative, so we want it as a plus. That is our greatest common factor. My recording's being a little slow right now. Okay, when you factored this, let's see. They both have an a they can give up, 1a. They both have b's they can give up. Now, they can both give up 2. He has 2 to give up. He has 3 to give up. So the maximum number you can take from both is 2. They do not both have a c they can give up. The second term here does not have a c. All right, so I found the greatest common factor, GCF. And now we're going to figure out what would be left behind. So 1a was pulled out of here, which means there are still 2 a's left, a squared. 2 b's were pulled out, means there's no more b's left inside. And this c still needs to come along for the ride because he was not pulled out. Plus, all right, I pulled 1a out, so there's no more a's left here. We pulled 2 b's out, so there's still going to be 1 b left behind. And that's it. One more, a little bit uglier, but it's good practice. So take your time, see how good you can get, pause the video, and do it right now. All right, so greatest common factor of the numbers is 8. Oopsie. Greatest common factor of the, well, I'm just going to go in order. P's. How many p's can both pieces give up? He's got 5 he can give. He's got 2. So the maximum they can both give up is 2. So we're going to pull out a p squared. R's. He's got 3. He's got 1. So that means 1 is the maximum number I can take from both of them. S's. He's the only one with an S, so I can't take S's out. And T's, he's the only one with a T, so I can't take T's out. So that is my greatest common factor. Now what's left behind? After I've factored this pieces out, I would have, my first term would look like, well, 2, because 8 times 2 is 16. 2 p to the third power, because p squared times p to the third power is p to the fifth power. I'm not going to have an r here because I pulled him out. He was the only r this first term had, so he's not going to be inside. But I am going to have a t cubed, t to the third power here. All right, minus 3. Pick up the pace a little bit. No p's left inside. They were all taken out. But I have r squared. And that would make this r squared and that r to the first power. Multiply to give us an r to the third power. And I would have my s on the inside as well. And that's it. Now, solving an equation by factoring. Well, really what we're going to do is we're going to do what we were just doing the previous 2 types of problems. We're going to factor this first, because right now if you're looking at this equation going, man, I don't have any clue how to solve this. But if we would factor this and say, okay, well, what can both of these terms give up? Right now, these both terms can give up a 2x. And what would be left behind? Well, an x plus 4. Right? 2x times x is 2x squared. 2x times by 4 is 8x. So this is the same factoring we were just doing in the previous problems. So the 2x right here would be the greatest common factor. But I have 2 things, 2x times by x plus 4. 2 things multiply together that equals 0. So I know either 2x equals 0 or x plus 4 equals 0. And so I'm going to solve both of those equations, either x equals 0 or x equals a negative 4. And that's it. That equation is solved. So that was factoring first, then using that zero product property. If two things multiply together equal 0, set both things equal to 0 and solve. Okay, you try one. Try letter B here. So your factoring should look like, the only thing you can pull out from both of these is a p. So you're going to have p plus 3 left inside. And then we would use our zero product property. Either p equals 0 or p plus 3 equals 0. This side's already solved. The left side's already solved. On the right side, if we subtract 3 on both sides, we're going to get p equals negative 3. Okay, 2 for me. So let's see here. Letter C. Well, we can't use the zero product property very well if the equation's not set equal to 0. Like, do you see how there's things on both sides of the equal sign? We don't want that. We want everything on one side so that it would be something equals 0, like this one. So I'm going to start by adding h cubed to both sides, so that now on the right hand side they would cancel, but on the left hand side we would get a new expression that we can solve, or at least factor. Both of those terms have an h squared they can give up, and then left inside I would have an h plus 4. H squared times h is h cubed. H squared times 4 is a 4h squared. Set both pieces equal to 0. Either h squared equals 0 or h plus 4 equals 0. The right hand side, when you subtract 4 on both sides, h equals negative 4. On the right hand side, or on the left hand side, h squared equals 0. The way that we solved square roots in the past, or squares in the past, is by square rooting both sides, giving us h equals 0. I mean, if I take the second square root of 0 is 0. Okay, letter D. Both terms have one r they can give up. That is the greatest common factor, the biggest thing I can pull out of both of them, giving me 3r. Ooh, what do we put down? If we've taken all he had to give, we gotta have something here. We gotta, like, what r times by what would give me r, not 0. If you put a 0 here, r times 0 is 0. We need it to be a 1. Just like if you have a fraction, something divided by itself equals 1. Well, here I'm taking r and it's almost like dividing the whole thing by r, reverse multiplying, which is divide. We would get 1. So r times r, 3r is 3r squared. R times a negative 1 is a negative r. Now that we've factored, we can set both these things equal to 0 and solve. The left side is already solved. R equals 0. Great. On the right side, when I add 1 to both sides, we're going to get 3r equals 1. And then when we divide by 3, r equals 1/3. And we would leave this as a fraction. Okay, Here are two for you to try right now. First one, you should start by adding 20m to both sides, giving you m squared plus 20m equals 0. We're going to factor an m out of both pieces. When we set both pieces equal to 0, we have two simple equations that we can solve. So either m equals 0, like we have on the left, or when we subtract 20, m equals a negative 20. Letter F, both terms can give up a 3k. That's the greatest common factor. What's left over is a 3k plus 2. Then we set both pieces equal to 0. 3k equals 0, or 3k plus 2 equals 0. Solve both. On the left, we get k equals 0. On the right, we would subtract 2 on both sides. And then we would eventually divide by negative 3. We get negative 2/3 as our answer. Two more because practice never hurt, and this really is the foundation for the next 5 lessons. Factoring something, then solving the equation. So it's good to make sure we understand what we're doing. So go ahead and pause the video, try these two right now. Okay, so I'm going to subtract 3y on both sides. Y squared minus 3y equals 0. I can factor out a y from both pieces. Y would be the greatest common factor. We can then solve, so y, or set up our two separate equations, the zero product property here. So either y equals 0 like on the left, or y would equal a positive 3 on the right. I would just solve by adding 3 to both sides. Letter H, although the terms are slightly out of order, we usually have the m squared piece first. This is we can still solve. I mean, I can still factor out an m, giving us 3 minus m equals 0. So either m equals 0 or 3 minus m equals 0. Well, the left side's already solved. He's done. The right side, well, maybe take 2 steps to solve. You're going to have to subtract 3 on both sides, then divide by negative 1, and m equals a positive 3. Application. So this application is something that's going to pop up sporadically throughout the next few lessons. It's used because, well, it's a very common use of a polynomial. Okay, it's a simple polynomial. This polynomial, what it shows, it's a formula that can find the height of an object after a certain amount of time. And you do not have to remember this formula. I will give you this formula in every single problem that it's needed. Okay, so this formula shows, I mean, if you would throw an object in the air, it kind of makes a parabola shape. Well, over time, second 1, 2, 3, 4, 5, 6, based off of the starting height, where the thing, I mean, like throwing something off a cliff is different than standing on the ground and throwing it. So starting at your starting height and the initial velocity, the speed that you're throwing the thing at, we can calculate how long, the time in seconds, it would take for this thing to reach some other height. We could figure out the top of the parabola. We could figure out when it hits the ground, all sorts of things. So here's one. In his attempts to save the princess, Mario must jump to many platforms. If he jumps straight up with a velocity of 18 feet per second, how many seconds does it take for him to land back on the ground? Okay, so we've got things we can plug in. His initial velocity is 18. We're going to plug that in for the v. So certain things we can leave. What do we say, 18? Yes. Okay, his starting height. Well, he started on the ground, so his height would be 0. His feet would be at ground level. So he's starting at ground level at 0. So let's see. How many seconds? So we don't know the number of seconds. We don't know the time. So that's going to be our variable. That means we must know the final height. How many seconds does it take for him to land back on the ground? Oh, so his final height will be on the ground, 0. And if we simplify and solve this equation, we can actually solve and find the number of seconds t that he was in the air. So let's see. So first off, I'm going to simplify. This whole plus 0 thing is not needed. Oh, look at that. We have a polynomial that we can factor. I can pull out a 2. Do I want a 2 or a negative 2? I don't know if it really matters. I'm going to pull out a 2t. Because both of them have a t they can give up. Both of them have a 2 they can give up. That makes this is going to become a negative 8t. And this becomes a plus 9. All right? If we'd multiply this back out, negative 16t squared, positive 18t equals 0. Hey, that's two things being multiplied together equals 0. That is 0 equals either 2t equals 0 or negative 8t plus 9 equals 0. Excuse me, I had to sneeze. So then we solve both. Divide by 2, t equals 0. Minus 9 on both sides. Negative 8t equals negative 9. Divide by negative 8. And over here, t equals a positive 9/8. So Mario's feet are on the ground at time 0, at 0 seconds, and 9/8 of a second, which 9/8 is just over 1 second, 1.25 seconds, or 1.125. So it takes him just over a second from jump to back down. So the final answer we're looking for is, how long does it take him to land back on the ground? 9/8 seconds. We don't want this one because that would have been like when he first started. So he's going to jump up and land back down. Here's time 0, and as he's going, time's ticking off, and right here at the end, that's 9/8 seconds. That's just over a second. Okay, one for me, one for you. As Princess Peach is running away from Bowser, she must jump over his fireballs. If Princess Peach jumps straight up with a velocity of 24 feet per second, how long would it take her to land back on the ground? And I've given you the formula again. Notes, start height, final height. I can't squeeze it in there. V is velocity, speed. T is time in seconds. So why don't you go ahead and pause the video. and do this problem right now. All right, so final height is 0. Starting height is 0. She's on the ground, she jumps up, she lands back on the ground. Velocity in this problem is 24 feet per second. And everything else comes along for the ride because, well, we don't know the time. Just like the previous problem, this starting height piece is going to go away because it's just plus 0. And so now we're going to solve this equation. So I'm going to factor, let's see, out of those two terms, I can pull out a 4t or a negative 4t. Let's do negative 4t this time. Let's see how it's different. Which means left hand side, I'm going to have a positive 4t. Negative 4t times positive 4t is a negative 16t squared. This would become a negative 6. And I'm double checking. Negative 4t times by negative 6 is 24t squared. Okay, it all works. Since these two things are set equal to 0, I can say, well, either negative 4t is 0 or 4t minus 6 is 0. And then I solve both. Divide by negative 4, which is kind of dumb. I don't need to do that because 0 divided by anything is 0. So that's probably the one she started. She started on the ground at time 0. At 0 seconds, she's still on the ground before she jumped. Now, after the jump, let's see. We add 6 to both sides. 4t equals 6. Divide by 4 on both sides. Over here again. And we get t equals 6/4, which is 1.5. So she lands on the ground after 1.5 seconds. And by the way, this formula that is here, this is not a made-up formula. This is the exact same formula that in physics class you will use and physicists use to calculate, if you ever hear like somebody dropped a bowling ball off of a building. Well, this is the formula that talks about gravity, this negative 16t squared. That's your gravity. This would be and this velocity here would be like, instead of somebody like throwing it up in the air, if you threw it straight down the ground, your velocity would be a negative and make it go to the ground faster. So this is the actual formula that sciencey people use to calculate something that's being thrown, hurled, because everything that you do, because it's affected by gravity, moves in this parabola shape, and that's the formula for this parabola shape. So it's kind of cool that this actually does work. Summary: how can using the zero product property help us solve polynomial equations? So think back on all the different times we use the zero product property. How did that help us solve equations? Go ahead and pause the video and think of a solution or think of an answer. Well, it allowed us to solve equations that before this point we had no clue how to solve. We did not know how to solve this. So once we learned how to factor this into two smaller pieces, and we learned that the zero product property says that if two things multiply together equals 0, we can set both of them, one or both of them equal 0, and we can find the solution of the equation by solving smaller, simpler equations. This is a much smaller equation. That's a much simpler equation than the original. Okay? Thank you so much for watching, and sorry about the choppiness of the video. Hopefully everything was okay with the audio. And until next time, toodles.